Hello, my name's Daryl Corn, and this is my walkthrough of Homework 3 for Intro to Machine Learning. Let's dive in. Okay, we will start with my code. This is my notebook with my Python experiments for the k-neighbors classifier. So I will run it right here. You can see that we bring in some packages here to test everything. We split our data, and then we get into the k-neighbors classifier, which I created a function to do this. You can see here we're bringing in our cross-validation. So we're splitting it into 5 cross-validation. We're iterating over different values of k. I'm using k20 as the max, and we're also iterating through different distance metrics, Euclidean, Manhattan, and Chebyshev. And then in the function, we save some of the scores. We print out a nice plot. And so this one is running right now. It takes a little bit of time to run, so I'm only going to run maybe one of these. You can see that I use this function 5 times, 1 for unscaled data, and then 4 more for different scalars, so standard, min-max, normalizer, and robust. And if we wait just another second here, we should finish the first one. There it goes. And I'm going to interrupt it now so that we can move on with the presentation. But yeah, it generates graphs like these comparing the test and training accuracies. Okay, so for logistic regression, I'm not going to run this one because it takes a long time, but it's the same deal as the last one. We bring in cross-validation to test the logistic regression, although I did name the function the same name. But yeah, cross-validation, and we're testing different C values for that. And that creates graphs such as that. And lastly, the linear support vector machine classifier. I can run this one because it runs super fast. Same as previous ones, we test different Cs. We test on 5-fold cross-validation. We print out our graphs, and we have such graphs such as this, comparing our test and training accuracy over different C values. And lastly, I have this notebook where I take the best parameters from all of the previous experiments, and I create 3 more functions, and I just test how they're doing. So we compare the training and test accuracy on the whole data set there, and then we compare some of the misclassified samples that they generate. Okay, on to my results. So we'll start with the k-nearest neighbors binary classifier first. I know it's kind of a busy page, so sorry about that. But what we have going on here is I have one graph for each of the different scaling techniques, and they're showing the validation and training accuracy for each of the different metrics. And generally, I'll just summarize it for you. We definitely see that the Manhattan distance always gives us the best accuracy for each of the scaling techniques. And we also found that of all the scaling techniques, unscaled gave us the best results. Somehow scaling the data impacted our results, which is interesting. So figure 2.1 here has the highest accuracy, and we can see with the Manhattan distance, we had our best K at 3, which I show in this page as well. So unscaled K equals 3, 99.57% test accuracy. We also have in this figure here at 3.1. This is where I'm just showing the accuracies for the different scaling techniques, and we can see that unscaled in purple here is way higher than all the rest. Okay, on to logistic regression. Same deal here. We have 5 graphs for the 5 different scaling techniques. And again, we see that the unscaled data gives us our best results, which is really interesting. Also, it was also the only one that we see signs of underfitting. As we can see, then that's the steep drop off here in figure 4.1, and even a little bit of overfitting beforehand. But in these other graphs, figure 4.3 4.2 all the way to 4.5, I don't see any evidence of underfitting, which is really strange. Definitely see signs of overfitting, though, as these curves. So, to sum up our logistic regression tests, I read in the documentation that by default it does use L2 regularization, something to keep in mind. But the best scalar technique was unscaled at a C of 0.001, and that gave us an R squared score of 99.91%. All right, lastly, the SVM classifier. Here, we did find that scaling the data did make a difference, which I was happy to see, really, because that makes more sense in my mind. We also, though, do not see any signs of underfitting, even in the underscaled data, or the unscaled data, sorry. But we do see that there are signs of overfitting for most models all the way up to C equals 1. And to just kind of summarize our best parameters. So for the linear SVM classifier, I did find that the standard and the min-max scalar, they led to the same amount of accuracy at 99.74%. But between these two, I decided to go with min-max as being the best parameters because that used a C-value of 10, whereas standard scalar just used 100,000. So essentially, I don't think there's really any regularization on the standard, whereas min-max is using a little bit of regularization, and so therefore I think it would generalize better. So that's my best SVM classifier. Let's get into comparing these different models. So for this one, I compared the cross-fold training and test accuracy listed in these two columns in figure 8.1 to the training and test accuracy of the model with the best parameters on the whole data set. So that's the difference between these columns. And we see from these tests that k-nearest neighbors and logistic regression, these two, they improved their scores just a bit when we switched from cross-fold to the entire data set. And interestingly, the support vector machine, its scores decreased a bit when we switched to the entire data set, which is very interesting. And I don't think from these scores we see evidence of underfitting, but I do think we see evidence of overfitting, particularly for logistic regression. We see here that it got 100% the training accuracy. So I'm doubtful to say this is our best option. Let's see. I think that's all I'm going to say for this page. We're going to move on, and then we'll talk about our best, what I think is the best model on the last screen in the conclusion slide. Okay, so just to compare some misclassified samples, the k nearest neighbors, that got 3 test samples wrong, displayed here in figure 9.1. Logistic regression got 1 sample wrong, and then SVM got 4 samples wrong. So we know from the documentation that the target class 1 is spam and 0 is a valid email. And so it appears from figures 9.1 and 9.2 that sample 1090 was really tough because k-nearest neighbors and logistic regression both got it wrong. So I guess somebody wrote their email in a very spammy manner because they both got it wrong. SVM did not get it wrong, but it got 4 entirely different samples wrong than either of the other two. And one other thing I wanted to mention about these results is that it seems we're getting a fairly even spread of classes misclassified. So I wouldn't say any of our models are struggling at classifying any one class. It seems to be a fairly even error rate, which is something to be said. Okay, so let's conclude this. I know we're running out of time. In my opinion, I think the k-nearest neighbors model showed the best ability to generalize. logistic regression and the SVM, we know logistic regression got 100% of the training data memorized, and SVM was also the second highest amount, highest accuracy on the training data. So K nearest neighbors, it did the worst on the training accuracy here, but it did have the second highest test accuracy on the entire data set. So I think that makes it the best candidate for this problem. Some things to mention about K nearest neighbors. It does take the longest to train out of all these models, but this doesn't really take that long. It's probably just a few seconds more than everything else. So I don't think it's really that big of a deal in the grand scheme of things. It also is kind of hard to interpret, especially at very high dimensions. It's probably not as difficult as SVM, but it's definitely harder than logistic regression. So that, I believe, is concludes my homework. Again, the parameters we chose were unscaled, and k equals 3 for the k nearest neighbors model. So thank you for listening, and that concludes my homework.